Good morning. This is your Stat Sensei, Mr. Spensei, and this is an exit ticket on paired t-test. And we're going to do a confidence interval. And scenario drugs for cheap is our scenario. So, a growing number of employees are trying to hold down the cost that they pay for medical insurance for their employees. As part of this effort, many medical insurance companies are now requiring clients to use generic brand medicines when filling prescription. The consumer group wanted to compare the active ingredient in name brand drug and its generic counterpart. They randomly selected 10 pharmacies in a large city, filled prescriptions for both the name brand and generic, and tested a pill from each prescription to measure the active ingredient. Results are shown in the table. All right, so initially this showed 20, and I did not want it to be 20. If it had been 20, this would have been a two sample T. But as you notice, we have 10 pharmacies chosen, and we happen to have 10 data points for each one. That means each pharmacy was tested twice. So they took some name brand from one pharmacy and the generic from one pharmacy, and they measured it out. So this makes this a paired t-test because the pharmacy was measured twice. I input that data into stat edit, and it's an L1 and L2. I go to the top of L3 and I press blue button 1 minus blue button 2, and it populates it for me. Okay, so it says create our exit ticket is to create a 92% confidence interval for the difference in active ingredient. Well, our formula for this is going to be X bar D, so the mean of the sample, plus or minus T star, the number of standard deviations of the T distribution, divided by the square root of n. And the reason we're using a T distribution is because we're going to use the data from the sample. All right, so stat calc, one variable statistic, blue button 3, and I end up getting an X bar of negative 3.3 because I went generic minus name brand, which is L1 minus L2. That's what I did. We have a sample size of 10, or we have 10 pairs, and degrees of freedom are going to be 10 minus 1, which is equal to 9. And we can look and see the standard deviation of the sample is 4.85, 4.7853. All right, we need to calculate our T star. You don't need to write down this, but we're going to have to do an inverse T, and it's going to ask for our area. In this case, our area is going to be 1 minus 0.92 divided by 2 with the degrees of freedom of 9. Oops, of 9, not in. All right, so second vars, inverse norm, area, parenthesis 1 minus 0.92. Oh, excuse me. Second vars, inverse T, area, parenthesis 1 minus 0.92, close parenthesis, divided by 2. Degrees of freedom in this case are 9, or 10 minus 1. And we end up getting 1.9726. Always make it a positive number. So T star equals 1.9726. I'm going to go ahead and plug that in, and I'll have negative 3.3 plus or minus 1.9726 and 4.7853 divided by the square root of the sample size. Make sure you use the sample size and not the degrees of freedom there. All right. Unlike hypothesis tests, confidence intervals are centered on X bar. And our X bar in this case is negative 3.3. And the reason they're centered on the sample mean is because we don't actually know the population mean when we're doing a confidence interval. We're trying to estimate it. So this is 0.92. This is my lower. This is my upper. Not that they asked for it, but alpha equals 1 minus 0.9. Try again. Alpha equals 1 minus 0.92. So alpha equals 0.08, which means in this tail, I have 0.08 divided by 2, which is 0.04 in this tail, and 0.04 in this tail. And if I added those values up, it'll add up to 1, 0.04 plus 0.92 plus 0.04. And those are the values we have drawn. That adds up to 1. The inference procedure used: one sample paired t interval. And I'm going to write for means. All right, our interval. So we're going to run this thing and we're just going to go stat test. And we're going to drop down to number 8, which is t interval. We have data, so make sure data is highlighted. Blue button 3, because that's where our differences are located. We change our confidence level to 0.92. And we have a lower bound and an upper bound. So basically, we expect it to be the difference to be negative 6.285 to negative 0.3148. This is my lower, this is my upper. And what that's saying is because it's less negative, we're saying, hey, the generic appears to have less active ingredient. We're 92% confident that the range is somewhere between here and here, with the generic having less active ingredient than the name brand. All right. Appreciate you watching. Look forward to seeing you on the next one. Thank you.